Hi there. For this video, we'll be talking about two of the special products in multiplying binomials. So the first one is called the sum and difference. So basically, what this tells us is that if we multiply x plus y, a sum, and x minus y, a difference, the outcome is simply x squared minus y squared. Indeed, if we apply the FOIL method, observe that the first terms, multiplying this, will have x squared plus multiplying the outer terms would give us negative xy plus multiplying the inner terms would give us xy plus multiplying the last terms would give us negative y squared. And observe that in the middle, these two out here would cancel out, leaving us with x squared minus y squared. So let's show some examples applying this one. So if we have 2x plus 7 times 2x minus 7, multiplying this would give us 2x squared minus 7 squared. And note that this one would distribute here by the laws of exponents. So we'll have 2 squared is 4, then x will be x squared minus 7 squared is 49. And so that is the answer for this one. Let's have one more example. If we have 8a squared plus 1 times 8a squared minus 1. First, we'll have 8a squared minus 1 squared. And similar to the first one, the 2 here will distribute to the 8 and a squared. So we'll obtain 8 squared is 64. A squared will give us a raised to 4 minus 1 squared is simply 1. And so that is how sum and difference works. Let's move on to the next one. This is called the square of a binomial. Now for this one, if we have x plus y squared, the outcome for this one is x squared, or the square of the first term, plus 2 times the first term and the second term plus the square of the last term. Indeed, if we apply the FOIL method out here, we can view this one as x plus y times x plus y. So we'll obtain the first term, x times x, would give us x squared plus the outer terms, x times y, would give us xy plus the inner terms, y times x, would give us yx, or simply xy, plus the last terms, which are y times y, and will give us y squared. Simplifying this, we'll obtain x squared plus, observe that these are like terms, so we can add them if we assume that there are ones out here. So we obtain, we'll obtain 2xy plus y squared. And so we take note of this one. And as an exercise, you can verify that x minus y squared, x minus y squared is equal to x squared minus 2xy plus y squared. So let's have two examples. First, let's have 2x plus 3 squared. First, we square the first term, which is this one. So we'll have 2x squared plus 2 times the first term, 2x times the second term, which is 3, plus the square of the last term. So we'll have 3 squared out here. And so this one would result in 2. Again, we can distribute this 2 out here. We'll obtain 4x squared plus, simplifying this one in the middle, will give us 2 times 2 is 4 times 3 is 12. So this will be 12x plus 3 squared is 9. And so that is the answer for this first example. Let's have one final example. If we have x minus 7 squared, this would become, first we square the first term, so we'll have x squared, and since we have a subtraction operation, this will be subtraction. So this will be 2 times the first term, which is x, times the second term, which is 7, and lastly, plus square of the last term, which is 7 squared. Simplifying, we'll obtain x squared minus 40x plus 7 squared is 49. So that is the answer. And so that is how we multiply or apply these special products, namely the sum and difference and the square of a binomial. On the next video, we'll be focusing on what we call the binomial theorem, especially if we deal with cases such as, say, if we have a plus b raised to 3, or raised to 5, or raised to 10, since it will be troublesome if we simply view this as a plus b times a plus b 10 times and apply the FOIL method repeatedly. That would be troublesome. And so that's it for this video. I hope you learned something from here. And yeah, that's all for this video.